Welcome to the OMSAI Academy. Today we are going to see some of the questions of class 9 work and energy. So we have given couple of questions to our the offline batch, and if you are interested to join this offline batch, please do contact us. The contact details have been given in the video descriptions. Please go through it and contact the offline. Contact us to join this offline batch. Here are a few of questions we are going to sort, not all the questions, but if you want the remaining questions too, then please do comment in the comment section so that we will do the remaining questions too. Okay, so let's start with the first question. Just pull out the questions. Yeah, so first questions is something, let me paste it out, this question. That question is here. Question is here. I hope you are guys able to see the question. Let me just zoom little bit. Yeah, so the question is that give one example each of potential energy due to its position and due to its shape. Okay, so guys, you know the potential energy. Potential energy is a something, the energy is possessed due to its, oh so sorry, yeah, so potential, what happened, one second, yeah, it's pain now. So potential energy, first of all, let's understand what is potential energy. So potential energy is the energy possessed in the body due to its shape or due to its position, called as potential energy. And everyone knows the formula of potential energy is mgh, where m is stand for the mass of the body, g is the gravitation, and h is the height of the object from the ground. So this is the formula of the mgh. Now the question asks, give the example where the potential energy due to its position. Now we know that when we let's say there is a some place, or you can consider, is a very famous example, that the storage of water above the from earth. Okay, now we know that there are some places where water is above the ground surface, right? For example, the waterfall, right? So if you look at the waterfall, in the waterfall, you know, the water is stored at some height from ground, right? So the energy possessed in the water is a potential energy. Second example, for we can take the second example due to its position, is that when we are building any buildings, or the uh, house, so the bricks which is from above the ground, okay, it's also had the energy that brick has, is again the kind of potential energy, right? Second question asks due to the shape. Now there are two examples I want to give here. The first example, let's take a rubber band. Okay, so when you stretch this rubber band, its shape gets changed, right? It get elongated. So the energy possessed after the elongation, okay, due to the elongated shape, this is what, this is a elongated shape. So the due to its shape, the energy possessed in this is again, it's a potential energy. The second example, if you take the arrow, archery, if someone playing archery knows that when you stretch this string, okay, the shape of this arrow, or you can say the bow and arrow, uh, this is getting stretched, okay, the string where you keep the arrow is getting stretched. So the energy possessed after the stretching is again, it's a kind of potential energy. I hope you understand the example of potential energy due to its shape and due to its position. Okay, now let's move to the second question. The second question is about, let me paste it first and then we'll start. The second question is that what is the work done by the force of gravity on satellite moving around the earth? Okay, very nice question. Let's focus on here. See, this is the earth, right? We know it. This is the earth. Sorry for that, it's not completely circle, but it's earth. Okay, and we know that there are a couple of satellites, many satellites are moving around the earth. Okay, now the question asked is that what is the work done by the force of gravity on a satellite? We know that whenever the satellite is moving, around the earth, the force of gravity is always a perpendicular to the earth. Okay, you can keep the satellite anywhere. The force of gravity on earth is always what? Perpendicular. It is always what? Perpendicular. It is always what? Perpendicular. Okay, so when I say perpendicular, means it is the 90-degree, correct? And the movement is a tangential. Okay, if you look at the tangential, means it's tangential to this path. Okay, this is what? This is a path of the satellite, right? Now if you look at here, the satellite is moving the tangential movement. The satellite is moving is a tangential movement. The satellite is moving here a tangential. So the direction of the displacement, or I can say this, yes, displacement. So this is a displacement, this is displacement, this is displacement, this is displacement. So the movement from the displacement and the force is how much? Is 90-degree. Now we know that how we can calculate the work. The formula for work is force into displacement into cos theta. Now the force of gravity is there, displacement is there, but the theta between the force and the displacement is 90-degree, right? And we know that as per the trigonometry, the cos 90 is 0, so work done is also equal to 0. So this is the justification to your answer. What the question is asked, what is the work done by the force of gravity on a satellite moving around the earth? Okay, so work done by the moving around the earth is a 0, because the force of gravity and the displacement have the angle is 90-degree, and because of that work done is a 0. I hope you understood this question and their explanation. Let's move over to the next question. The next question is again the theoretical question. It's that explain, replace this. Okay, so the question here is that explain the law of conservation of energy with the help of pendulum, right? Pendulum. Now before moving to the pendulum, what is law of conservation of energy says? The law of conservation of energy says the energy neither created nor destroy, yes, nor destroy, it is converted into one form to another form, right? This is the law of conservation of energy. Now if you look at the pendulum, okay, let me just draw the pendulum first and then I'll explain with the help of diagram. Now if you look at the pendulum, so let's say this is the rigid portion where the pendulum is connected, and the bob, this is called as a bob. Okay, this is the original position. When pendulum start from this position, let's say A, move to the B, okay, and again go to the position C, right? Now when pendulum start from this place to this place and stop, at the moment of stop, the kind of energy this bob has called as a potential energy, right? Because when the object stop, the kind of energy saved in that bob is potential energy. Now when bob start moving from this position B and start moving towards the A, the kind of energy bomb has is potential energy plus kinetic energy. Again when, so what happened? Now here is the potential energy is very high. When bob start from point B and start moving to the A, its potential energy is getting reduced and kinetic energy getting high, because now bob is in the motion, and we know that when any object is in motion, kinetic energy is getting increased. When it reaches to point A, its potential and kinetic energy is very high and potential energy is 0. Again, from A to C, when warp start, kinetic energy getting reduced, like potential energy. Again, here is potential energy plus kinetic energy. And when it stop here, its kinetic energy is 0, but potential energy is high, right? And in this way, we can see that the energy, so potential energy is here, potential energy is here, but it is in between its potential energy plus kinetic energy. So point B start potential energy converted into the kinetic energy. Again, kinetic energy is converted into the potential energy. So this say that if you look at this diagram, at all stage, okay, at all stage, so location A, it's kinetic energy. Location B, it's, one second, okay, give me just a minute, let me erase this. Yeah. So if you look at the, okay, so if you look at the point B, here point B, it's having potential energy. Then it's, when it bob reach at A, it has kinetic energy, and when it reach at C, it has again potential energy. So energy is only getting what? Converted, okay, but not created. And this proves that the law of conservation, the energy converted and not destroyed, sorry, energy is not created nor destroyed, but is only converted into from one form to another form. I hope you understood. Okay, the next question is that if energy is neither created nor destroyed, then from where do we get the energy? Again, the same question, but only it's the question, this kind of question always, uh, confuse the student, but it is very simple question. This question is based on the law of conservation of energy. Law of conservation of energy. What law of conservation of energy? In previous question, we saw that energy neither created nor destroyed, it's converted from one form to another. So what is expected here? You definitely you state the law, but give some example. For example, when we, if you look at the home, right? In home, there is electricity, right? So when we switch on the electricity, okay, we pass the current, fan gets started rotating. So what it happens? Electrical energy is converted into what? Mechanical energy. What kind of energy? Mechanical energy. Similarly, if you look at the another example, when electrical energy pass, our tube light or our bulb, okay, uh, get lighted, okay. So the electrical energy is converted into which form of energy? Light energy, okay. And there are many as such example we can say. For example, in vehicle, right? The vehicle has some kind of engine. They get the energy from the petrol, right? So it's kind of fuel energy. Then it pass to the uh, engine. With the help of petrol, the engine gets started, so it converted into the mechanical energy. And similarly, we have battery. Because of that, the headlight of vehicle on, so it's again light energy. These are the example you can give in the exam, so that this will support your answer, right? I hope you understood. You can write in very descriptive. How much work done by a force of 10 Newton? Okay, so let's start with the given. Okay, how much force is given? Force is given is 10 Newton. Okay, in moving object through a distance of 4 meter. So the distance is, one second. So So distance is given 4 meter. Okay, and they have asked us to calculate work done. Now we know that what is the formula to calculate the work done. To calculate the work done is force into displacement. Okay, how much force is 10 into displacement or distance, you can say 4, so it's the 40. And what is the unit of work? Is Newton. Is the unit of force? Is a Newton. So work done by a force is 40. I hope you understood this simple question, right? And it is easy to solve. Let's jump to the next question. Question is that find the energy in a kWh. What is kWh? kWh, kilowatt hour. Okay, what is that? Kilowatt hour, right? Consume in a 10 hours. Okay, so the energy consumption, they have given us the time, right? The time is 10 hours. Okay, by a 4 device. Okay, 10 hour by a 4 device of power 400. Okay, so the number of devices, how much? 4. Okay, and devices of power 500 watt each. So the power of each is 500 watt. Correct. Now, so we have to what we have to calculate? We have to calculate the energy. Correct. So first of all, if you look at, they have given the power in 500 watt. Okay, of each. So what is the total power? How we can calculate the total power? So the formula of total power is 500, right? 500 into 4, it gives 5 4s are 20, and this is 2000 watt, right? Now, so we have to convert this watt into kilowatt because we want answer in kilowatt hour. Now we know that 1 kilowatt is 1000 watt. Okay, so 2000 watt means how many kilowatt? It's 2 kilowatt, right? We are going to use this power is equal to 2 kilowatt. Correct. Now to calculate the power or the energy, we know that what is the formula of power? Formula of power is W, or you can say energy, divided by time. So W is equal to what? Power into time, right? Now if you put this here line, if you say that power is 2 into time is 10, so it becomes 20 kilowatt. Okay, so the answer of this formula is a 20 kilowatt hour, because we know that the W and the energy is same, so the energy is equal to 20 kilowatt hour. So this is the answer of this question. Okay, so the next question here is that the power of heart, okay, the power of heart beats 72 times in a minute. Correct. So number 72 times in a minute is 1.2 kilowatt. Correct. Calculate the work done by the heart of each beat. Correct. So what we have to calculate? We have to calculate the work done for each beat. Correct. So let me just second. Okay. So we have to calculate the work done for each bit. Now how we can calculate? First of all, let me see, uh, it's a 72 times in a minute. Okay, so what is the formula of work done? Work done is a power into time, correct? So they have given the power in kilowatt. Okay, so let first of all convert the power is a 1.2 kilowatt. Okay, and if you convert this kilowatt into watt, so it's 1.2 into 1000 watt. Okay, so it becomes 12 00 watt. Okay, so it becomes 1200 watt. Now the time is they have given the power of heart which beats 72 times in a minute, correct? 72 times in a minute. So uh, 72 times in a minute, so in a minute means 60 second, right? 72 times, that means 70 times in 60 second. So 72 times in a 60 second. Okay, so this is happening in the 16 seconds, right? So let's calculate the first power. The power is sorry, work done is, let me just erase this. Okay, so the work done, so okay, so work done is equal to how much power is 1200 watt into time is 60. So this is the 12 6 is 72. So it's a 72,000. So it's a energy. But this 72,000 happened for how much? 72 bits. What we have to calculate? We have to calculate for the each bit. Okay. So work done to calculate work done for each bit is equal to 72,000 divided by 72, because this work done is for 72 bit, right? We have to calculate for per bit. So it 72, right, for each bit. So it becomes 72. Sorry, this is a work done for, yeah, it's a 1000 joule, correct? This is a 1000 joule. So how much, or we can write in the kilojoule as well. So we know that 1000 joule, or we can write 1 kilojoule. Both answers are same. I hope you understood this problem. Okay, thank you. Let's go to the next question. Yeah, so here is the next question, that a bullet of a mass 15 gram. Okay, so the mass of the bullet is what? 15 gram. Okay, so this is given in gram. We have to convert in the gram is the CGS unit, so we have to convert. Yeah, I think gram is totally fine. No, so gram is a CGS unit, correct? So we have to convert this gram into the kilogram. So how we can convert? We can divide the gram by 1000. Okay, so this becomes kg. Of speed is a 400 meter per second. So we have to calculate the kinetic energy, and we know that to calculate the kinetic energy, the formula for kinetic energy is equal to what? How much? Half mv square. So half into mass is given 15 divided by 1000 into v square. So v square means 400 into 400. right? I can write this way as well. So 0 cut, 0 cut, this 0 cut, this 0 cut, 1 0, one more is 0 there, this I can cut, right? Even I can write 2 2s are 4, so it's become 15 into 2 into 4. Now if you calculate 15 2s are 30, 34 are 12, it's coming 1200 joule, right? 1200 joule. So bullet of a mass 15, what is the kinetic? So this is the kinetic energy, correct? This is our the kinetic energy, right? So this is sorry, pen. So this is our the, let me circle this, make a box. So 1200 gram is our kinetic energy, correct? Now next they have 7, the bullet strikes this thick target and brought to the rest in 2 centimeter. Okay, in 2 centimeter, calculate the average net force acting on the bullet and what happens to the kinetic energy originally built in. Okay, now we know that when we say work done with respect to kinetic energy, it is always equal to change in a kinetic energy. Is a change in a kinetic energy. So when I say change in a kinetic energy, means it's a final kinetic energy minus initial kinetic energy. Now we know that when the bullet strike the thick target and brought to the rest after in 2 centimeters, so its final kinetic energy is 0 and the initial kinetic energy is how much? 12. Initial kinetic energy is equal to what? Initial kinetic energy is 1200. Okay, initial kinetic energy is 1200 joule, right? So it's a final minus, so final velocity is 0 as when it is rest, so definitely the final is 0, so it's 1200 joule. Now if you look at the formula to calculate the work done, there is a different formula, is force into displacement, right? We can ignore the negative sign, so it's become 1200. Okay, so force into displacement, so after how much distance is 2 centimeters, so 1200 into 2 centimeter, but this is in the how much in centimeter, so we have to convert into the meter. So let me first erase this. Erase this. So it's a, yeah, so it's 1 second. So here is, if you look at this, the distance is given 2 centimeter. So if you convert this 2 centimeter, it's become 2 meter, so it's become 100 meter. So distance become 2 upon 100 meter, right? 2 upon 100 meter. Now let's move to the this part. Let me change the ink. So it is a force into distance upon 1200. So force into distance, so it's 2 upon 100. Okay, consider this as a 100. Okay, so it's a 1200. So force is equal to 1200. 100 becomes on the numerator and 2 becomes in the denominator. So it's become 2 6 12, right? So it's become 60000 Newton. So this become 60,000 Newton, or one can write in the another form, that is 6 into 10 raised to how many zero? 4. So it's a 6 into 10 raised to 4 Newton. So this is your answer. I hope you understood. Thank you. Let's look at the next question. What it is saying, the given. Okay, first let's write the given. Okay, so what given it is given, oh, sorry, what they have given, the force is equal to 200 Newton. Okay, a horse exerts a force of 200 Newton to pull the cart if the horse cart system moves with velocity 36 kilometer per hour. So it is given 36 kilometer per hour. So we have to convert this into the meter per second first. So it becomes 36 into 1000 divided by per hour. So per hour means in 1 hour we know that 3600 seconds, because you look at this 1 minute as 60 seconds, right? So in 1 hour, which is a 60 minutes, so 60 into 60, it's become 3600 seconds. Okay, so that's why we have convert into this kilometer to meter and hour into second. So let's 0 0 0 0, 36 ones are 36, right? So 1 into 10, so it's become 1 into 10, it's 10 meter per, correct? So it's a 1 meter per second, correct? After that, they have asked find the power. Okay, now what is the formula of power? Power is nothing but the work upon time, right? One you should understand. Now if you look at the given thing, in our given, they only give the force and the velocity, correct? Now we know that to calculate the work, we have another formula called as a force into distance divided by t, right? Now here only we know that the force into distance upon time, if you look at this part, is nothing but what? Velocity. So the power is equal to force into velocity. So force is given how much? Force is given 200 Newton into velocity is 10 meter per second. The power becomes 2000, right? It become 1 2 3, yeah, 2000 watt, or one can write 2 kilowatt. The answer is same, 2000 watt or 2 kilowatt. So this way one can calculate the power. Anything they have asked? Okay, so they asked the power of horse in terms of horsepower, right? They asked to calculate the power in terms of horsepower. So to calculate the power in horsepower, we know that 1 horsepower is nothing but the 746 watt, right? 746 watt. So the power we have got 2000. If you divide this 2000 by 746, okay, whatever answer you will get, that answer is nothing but in the horsepower. Simple, nothing else. Okay, so you just need to divide your coming answer by divided by 746, you will get the answer of this power. You just find the answer and do comment in the comment section so that other will get benefited. Next, the next question, the last question of this, no, not last, second last question. Let me just copy paste first. Or yeah, so in the experiment, the power in the experiment, to measure his power, the student record the time taken by him running up flight steps of on a staircase. Okay, use the following data to calculate the power of the student. So we have to calculate the power of the student. So they have given the number of steps. So number of steps, number of steps is 28, right? Height of each step, height is 20 centimeter. It's 20, so we have to convert into the meter because we have to always calculate in the this unit, right? SI unit. And then time taken is 5.4 second. Mass of the student is 55 kg. I think that's okay. And the acceleration gravity is 9.8 meter per second square. So what we have to calculate? The power we have to calculate, right? Now they have given M, they have given J, and they have given the height, right? These things they have given, but they have given height of the each steps. So we have to calculate the height of the total height, right? So how we can calculate the total height? We just need to multiply this 20 divided by 100 into 28, right? So if you calculate 0 0 2 5 is at 10, let's keep it as a 28 by 5 meter for now, right? So 28 by 5 is the height. Now we know that to calculate the work or energy, this is height is given, so we have to use the formula of mgh. What is mass? Mass they have given 55 into g is the 9.8, but for sake we will consider 10 for simplicity, and the height is a 28 divided by 5. So 5 11s are 55, so answer becomes 11 into 10 into 28, right? When 10 is 280, 11 into 280, right? So we will consider this as a work. I'm not going to multiply just for the avoid any confusion. So whatever the answer, it's B. Now what is the power? Power is the work done or the energy upon time, work done upon time. So how much work done is done? 11 into 280 second, 280 divided by time is what? 5.4, right? So if you do this division by 5.4, so just to simplify, what I can do here is, so it's I'll add, I'll remove the point just for simplicity, and add it here, and 54, okay, 28 ones are 28, it becomes 100, 28 threes are, right, is 54. So it's become, let me just slightly this up, yeah. So power becomes 11 into 100 divided by 3. It becomes 1100 divided by 3. So this is the power which will come in the watt. So whatever answer, please do the remaining calculation and give it to me. I'll wait for your answer, how much power you will get, guys. Okay, and they are asked to calculate the power only, right? This power the student record applied, yes, they ask us to calculate the power. So you calculate the power, and please do comment in the comment section what is the power. Let's move to the next and the last question of this video. So let's start. First, when loading a truck, a man lift a box of 100 Newton each. So they have given force. The force is a 100 Newton, correct, each through height of 1.5 meter. Okay, so height is given 1.5 meter. Okay, how much work done he do in the lifting one box? Okay, and I think if you know the work is what, work is equal to uh, force into displacement. So force is 100, and how much distance it cover? 1.5. If you do the calculation, so it's become 150, right? 150 joule. So this much work is done by this simple question. You just need to understand. So this is the answer for the first A. Correct. Next, let me just move up. Yeah, second question. Second question, what, how much energy is transferred when one box is lifted? Definitely, as we know that this much of energy will transfer as per the law of conservation. So the answer for second is also the 150. Section question C. If man lifts 4 boxes per minute, okay, if man lifted 4 boxes, okay, 4 boxes per minute, what power he is taking? Okay, so the formula for power is again work upon time. Okay, 4 boxes, for one box he require 150, right? So if you calculate 150 into 4, so it's become 600 joule. Okay, now work is 600, right? Okay, so G, 4 boxes, 4 boxes per minute, right? So we have work is a 600 and the height is, yeah, and the time is 60. Okay, yeah, 60, 4 boxes per minute. So how much it becomes? 100. Okay, so power becomes 100 watt. So how much power he has? 100 watt. Correct. I hope you understood this explanation. If you guys have any doubt or any confusion, please do comment in the comment section. Till that time, all the best. See you in the next video. Thank you.